Well, through the magic of video, 24 hours has gone by. When I was testing this tube, which tested okay, my computer hard drive got full. So I had to deal with that. My wife came down and said, hey, let's go for a drive. And that ended up with me not getting back in here until now. But here's what we did on our drive. We went to see a waterfall called Bala Falls. I'll just show you a quick clip here. I'll make a video of our trip because we also went to another area called the Barron's Dark Sky Observatory area, and I took some video there. So I'll put a little video together, but here's a quick shot of Bala Falls. So there are three 6K7 tubes. This is the first one. In the radio, all of them amplifying either the radio frequency, this is a radio frequency amplifier, or doing the IF stage amplification. Any one of those has gone weak for some reason, then the output of the IF would be weak. So I previously tested all these. These all tested really good. I'm going to test them again. I have to at this point to be sure that they aren't the cause of what appears to me to be a problem anyway. So before I switch on the tester, let's just double check. 6K7, 6.3, signal 2, 33, L, 17342, 17342, 0610, 0610, 43 meter. C on the plate. Oh, wait. 43 D on the plate. That's correct. So this tube should read up around 1000 here when we test it. Okay, we're set. Away we go. So the last time I tested these tubes, I did it with a different tube tester. The other tube tester and this one have shown through my experience to be absolutely reliable. So let's see what this one has to say. Shorts, none, tube test. Oh, it's like the other one. These tubes tested really good in my other tube tester, so they're only supposed to get up to about here, and the needle's way up here. I really got that right. 1070. Yeah, 1070 is just right in here. Okay, so that's the RF amplifier. That's the first 6K7. I'll bring down the next and we'll test it. So this is an older style 6K7, the original style, I guess, 6K7G. Nice glass tube. Whoops, down here. Nice glass tube you can see in. You know, updated versions of this are metal tubes. Okay, I'm going to throw this in. Okay, grid cap on. Test for shorts here. All is good. Tube test. Just like the other one. Way up high. Surprising in a way, isn't it? A tube this old would test that good. Okay, there's only one more. If we're going to have tube trouble, it's got to be the next one. So this is also a vintage 6K7G, just like the last one. Okay, short test. All good. plenty strong. Each of these tubes tested 50% over the fail point. So I think that's really, really good. And I've been tested in two different tube testers with similar results, identical results really. So it can't be these tubes that are causing any weakness, but I have a couple more ideas. So the next theory I'm going to go on here is that, I'm not even sure why I show you the schematic here. The B plus used to be quite high in this radio. At that time it seemed to operate fairly well. The AVC voltage, you know, I only measured it occasionally and kind of sloppily, but here and there I did see it at 15 volts. There was a time where there was something popping in and out on this radio. I don't know what it was. You could see the magic eye suddenly closing as if it was getting a big AVC voltage, as if there was a bad contact or bad solder joint or something like that. That hasn't reoccurred. I haven't been able to track that down. That's one of the problems with intermittent problems. Perhaps that's gone. Perhaps that is the problem. If I can find it, then fixing whatever that is will result in the proper AVC voltage. And I'm only assuming that this radio should be generating a higher AVC voltage. I don't know that for absolutely sure. So one possibility is, now that the B plus has been dropped significantly in the radio, that other voltages applied to the tube have also dropped, screen voltage and the like. I would think offhand that's a good thing, but maybe what's happened is, with the dramatic change in the B plus, has allowed another problem to be seen that couldn't be seen before. And again, maybe it's around tube voltages or something of that sort. So I've also noticed when I've gone through with the signal tracer over here that the signal boost through the different IF stages is pretty minimal. But that's a little odd in itself. You would expect in fact, most of the boost in a radio comes in the IF amplifier, which would be this tube or this tube, because there's two of them in here. This is quite a radio. So you would expect the signal to come along, get stronger, and then carry on. But it doesn't seem to. And of course, this last coil has been changed with another coil. So there's quite a few things we can look at in the IF to try to determine if there's a weakness in there of some sort that's holding things back. Well, that's my next approach. I gotta think about it now. Okay, I think we're ready to start here. So I have the radio on restricted power at the moment. Let's hear it. That's the AM radio part, and you give it full power here. Let's listen to that. What happens? It gets ever so slightly louder. Not much else happens. Okay, so the objective here is to watch this meter as I check B plus and grid plate potential, screen potential, and stuff like that. So we're going to start right at the power supply output and see what's coming out of this. Now my scale on the meter is 500 volts, full scale. So the power supply voltage is 250 volts. And we should see that again right up here. 250. Good. Now I'm going to do the three 6K7s because it's the same tube, so it's the same pin all the time. They're all up here. Actually, I can only do two of them because the third one is, well, maybe I can get at it up here. Let's do the easier ones first. So the two 6K7s are these two here. I've got them labeled. These two tubes. What I want to do is get on pin 3. Let me just double check everything. Pin 3 is the plate, so we'll look at pin 3 on these two tubes here. Pin 3. Well, that's easier said than done. Okay, I see the key, I see the 3. Okay, So we're getting getting pretty much the entire plate voltage, or the entire power supply voltage. Okay, it's pin 3 there, pin 3 here. It's pretty much the same position. Very same voltage. Now we'll look at the screens. So the screens are pin 4. Yes, pin 4. So pin 4 should be the same or a little lower. That's what we would expect. That's what I would expect. 1, 2, 3, pin 4 on the first one. Ho, that might be a problem right there. So that's, what's that measuring there? The 500 volt scale, that's 50, 60 volts. I don't know that it's bad. Let's just keep going here. Pin 3 on the other tube is this pin here. Very low also. So we've got 2 with extremely, what I think are low plate voltages. That's interesting. What plate? Did I say plate? Screen. Screen voltages. Now, is this guy going to help us analyze this stuff? May not really. May not really do that. Grid number 2 volts, 125. That's the screen. Grid number 3, the cathode, right? Plate voltage 300 max, 250 typically. So we've got the right plate voltage, but we got way off on the screen voltage here. Guess who's arrived? Oh man, I can't seem to get anywhere without this happening. Where are you? Oh, you went out the door already. Okay. Okay. Oh, he's back. He's back. He's back. Yeah. That's him saying, "Come on out with me. Come with me." No, I'm not gonna keep doing this. So we're gonna listen to the cat. Now, there's one more 6K7. Let's go after it. The 6K7 is in here. Oh boy, pin 3. Well, just give me a touch more light here. Oh, peanut, really? Okay, 1, 2, 3. Pin 3's in the clear. Pin 3 in the clear. Pin 3 in the clear. Pin 3. Pin 3. Oh, I gotta put my head right in front of the camera here. There it is. Pin 3. I got 250 on that, and then pin 4. Again, right in the clear here. Pin 4. Oh, nothing. Yeah, even my cat's jumping up and down. Now, did I really get pin 4 there? Let's see. Oh, that would be the key. Then it's 1, 2, 3. No, maybe I didn't. I may have got these backwards. Let's try this one. So we didn't see anything there, right? Nothing there. It's hard for me to see the meter right now. And here we get plate voltage. And here we're supposed to get screen voltage. Oh, it's that same thing again. Screen voltage is low everywhere. Pretty sure. Pretty sure that's the state of affairs here. So the next step would be to look at the circuit diagram and try to figure out what it is that might be dropping too much voltage, or what the problem might be with this. But I think we got a quiet radio from low screen voltage, and maybe the really high plate voltage was somehow compensating for it, making these tubes operate in their more normal range. And also I have to settle down my cat. So next thing, schematic. Okay, so I sat with my cat, studied the schematic. It only took a couple minutes. It didn't even take that to recognize what the story might be here. So they've drawn the schematic, so it's really easy to trace the screen line. The screen, every one of these tubes gets its screen voltage from this line here. And this line comes down, goes through a single resistor, or I can't quite read it yet. and then attaches to the B plus source line coming from the power supply. So it's got to be that resistor, R something I can't quite read yet. R something there. I'll take a close look. We'll find it in the radio. We'll test it out. It's probably one of these big guys. In fact, I'm going to guess it's this one. That's my guess. Let me sort it out. We'll see which one it is and what it tests at. Well, the simple situation has become very complicated very quickly here, and it's forcing me to look at another part and feature of this radio that I've kind of ignored as much as possible, and it's these switches here that have now come into play in this circuit. There's two of them, one here and one here. So let's just take a look at this one here a little bit carefully. So I believe this is long wave, broadcast, I don't know, and short wave. What is that? Police band backwards? I don't know what that is. Look at the other switch and see long wave, broadcast, police, and short wave. So what is this switch doing? Well, if we look at this one, in this position and this position, it's doing nothing. Throw it here, it's basically presenting a short to ground, shorting out this resistor. It's removing this resistor. So by removing this resistor, by the way, I'm just thinking this through for the first time myself. This becomes the only resistor in the cathode circuit. What's that doing? That's reducing the bias on this tube. This tube's bias is entirely controlled, the grid bias is entirely controlled by this. There is no take it back, I take it back, I take it all back. Hold on, I'm taking it back here very quickly. So, I'm totally wrong. This thing, and suppressor grid here is just tied to the cathode as normal. So, going back to this still will generate a bias for the grid. It's just this grid here. This grid, I'm looking to see if it gets, this grid is affected by AVC also. Picks it up off this line here, which is the AVC voltage. You can see it going to the grid of the magic eye. So going back to this now, if you excuse me, if you decrease the bias, that makes the grid less negative. That makes the gain greater in this tube. The gain would be greater in this tube when this switch is in long wave or broadcast, and the gain would be knocked down by my reckoning anyway when you switch it to police band or short wave. Okay, so I'm going to analyze this one here. Now this is a little bit of a different deal over here. Oh, there's another switch right here. Oh my gosh. So this switch is switching, doing something with the voltage that's applied to all the screens. That's why the switch is implicated in this problem. And this switch, these are all gang switches, by the way. Obviously, when you don't move these independently, they're all part of the band switch. So they're all traveling together, obviously. This one, it looks like it's doing exactly the same thing that was happening up with this tube. It's reducing the gain of this tube when you head for short wave. Okay, that's what it appears to be doing to me, to my view anyway. This one, so this one's kind of opposite to the other two. When it's in these two positions, it's doing something. It's putting a ground on the end of this resistor, drawing current through here for reasons I don't know. But if you put it into police or short wave, this resistor's out of the picture. So this resistor is it's pretty clear on here that this is R11. R10 and R11. So let's take a look at what is going on with R10 and R11. R10, I'm going to want to probably find these. R10, 22,000, quarter watt, nothing special. R11, 18,000, 3 watt. Oh, okay, so this is one of the bigger resistors. R11. So this is the guy who's doing most of the work. Why this small resistor to ground? Why? So there could be something wrong with the switches, the resistors. It's not necessarily this one, although we're going to look at this one first. But I think I'm going to repeat that voltage test. I'm going to put the probe on, let's say, one screen, and then we're going to switch the band switch and watch what happens to the screen voltage here, and see if it doesn't come back or go away or whatever. It might give us a little more information to help confuse the picture. Let's go do that. Let's go confuse the picture here. Okay, excuse me. So, I just gotta fix my little lighting situation here a little bit. Okay. So we can now, you can see the meter in the background there. Let's just get ready. I'm gonna have to make a little change in the video in a moment to make this work well. We'll put the radio on. Okay, very good. And I'm going to clip on, I should have done this ahead of time. Okay, turn the radio off, I'll do this a little more safe. I'm going to clip this on to pin 3 of one of the tubes. This is a pretty good one here to clip. Right here. Okay, so that's a B plus line now, right on the meter. I don't have to handle it. Okay, not quite like that. Let's try. I don't know, that's even worse. Okay, we'll leave it down here. We'll leave it hanging down here. B plus will be up on the meter. Not B plus, screen voltage on the meter. And the band we're starting in is the AM band. And in the AM band, that switch is closed on R10. So the 22 ohm resistor is drawing through the 11, through R11. So if I switch this, long wave won't change it. Going towards either of the two short wave bands removes R22. Let's see what happens here. Let's see what happens. Okay. Full power right away. B plus sitting there. Okay, so you can just keep an eye right on this meter. And I am, wait a minute. I don't want to watch B plus, I want to watch the screen. Let me move the clip lead, but I'm going to once again shut the radio off during that little operation. Okay, back on. Now we're seeing the screen voltage. Okay, I'm going to operate the switch. Attempt to go to long wave first. But I'm always confused about which way to turn this. Here we go. Okay, so I think that's definitely long wave. Looked like a very small change, but that small change could be due to change in current flow through the tubes because I've done something here that's changed something. So that would pull down this voltage slightly, but I'm looking for something a lot more dramatic. Slightly up. Okay, here we go with the first short wave band. Almost no change. Next short wave band. Well, as usual, the results are not at all what I was expecting. Let's take a good close look here. That's the AM band again. This is the long wave. So long wave's down a touch. AM is at 6 volt mark, or 6, I'll just call it number 6 there on the dial. 6 volts. This goes a little bit higher, and then the last band a little lower again. Well, again, we're looking at kind of the total flow of current through all those tubes, and as I do this, there could be changes in the tube current flow that we're just seeing this here. So what this is telling me is working this switch doesn't do much. about the screen voltage. It remains really low. Now I did see on one of the schematics that I've got here, that I had here, that the screen voltage is written 95 volts. Really what we should be shooting for, and what we've actually got on there, 75 volts. Wait a minute, that's not that bad. I'm hunting down something that's not a problem. 75, I got this right. So that's 150 on the meter. Yeah. Just about 80 volts. That's just about correct. Chasing nothing here. Okay. Well, you know, chasing nothing isn't a waste of time, because it causes you to look at other parts of the circuit and stuff like that you might not be inclined to ever look at, and maybe you're going to find something, but maybe not in this case. Okay, so what we're saying here is bad screen voltage. No, not the case. And more tubes to check. So I found the screen and the plate voltage okay through the IF. So what's the next possibility? We can do a signal level trace more carefully through the IF, tube by tube, and see if there really isn't it should be building up. Maybe we'll see somewhere where something happens that makes us think, oh, that stage is the problem stage. Okay, so to do that, we'll try the signal tracer, and I've got to set up a signal for the radio to be chewing on while I'm doing this. Let me get the signal generator ready here. Put on the signal generator onto the antenna. What band are we on? We'll do this on the AM radio band. Okay, so that's the AM radio band. Unfortunately, my signal counter's in warm-up phase there. I'll have to give that another couple minutes. Radio's on, don't forget it. And okay, we'll get the signal tracer going here. Yeah, it has its own hum, as you can probably hear. So we want the signal tracer tracing 455, or 456 really. So we'll set this to RF, band A. 455 is way up here, 456. Right at the top. Okay, hook up the ground. Test probe. Now, seldom have I tried using this machine in a calibrated way, but we're going to try it this time. My frequency counter is still going wild, so let me just reset this camera. Here. That'll do it. It's not the best. That'll do it. Here's what we can see there. So now this instrument isn't really a quantifiable type instrument. I mean, it's not going to give me a meter reading. All we do is we set the eye closed, and then when we probe something else, we look at the eye and find out if it's closed or what has happened to it. We can compare from spot to spot. So we're trying to compare the signal strength as we work our way through the IF at 455 kilohertz. Here we go. I see my signal generator has returned to normal. Let me just flip back here. frequency counter rather. It's happy now. Okay, headphones on so I can hear. Volume up. And I don't know where the radio's tuned. I think it's tuned. It's not far from here. Let's see if we can find this. Oh, right there. Okay. Let me make one more change here to the video. Okay, I think we're set now. This is a kind of test I really don't do very often. Really haven't attempted this right up here. I want to get on the output of the 6A8 pin number 3, wasn't it? 3. 3 is the input up here. 3 is the input to this transformer. It's got you know 250 volts on it. I think that's okay. We're gonna find out here. Pin 3. Pin 3 down there, 1, 2, 3. It's in the clear. That tube doesn't seem to be set down all the way. No, it's not really. Oh, am I going to grab it and try to push it down further? I'm sure it's far enough. Okay. Now, 3, 1, 2, 3. Oh boy. Can't see. Okay, watching that. I gotta get this set so I can look away from it safely. Oh my gosh. So let me turn the volume down on the box here. Okay. 1. Oh. 1, 2, 3. Right in there. There it is. Okay. Okay, now. Doing anything stupid. So there should be a 455 signal there. Okay, there it is. Turn off the internal sound. All you're hearing now is microphones and the sound from this. Not moving that eye at all. So I have a you can't see it there. I have this control set fairly high, so we're going to turn down the volume. I'm going to change this. Unfortunately, you can only see so much, and the object is to get this eye to be closed. Wow. The order I'm doing this in. Okay, so what's happening now is that the volume is independent of the eye. There's a volume control. This is measuring the signal earlier in this signal tracer. I've set it now so the eye is just closed. Now what I'm going to do is move off of the output here to the output of the first amplifier. So I want to go here, take this out, and I want to get on the after the first tube, after the first IF tube. So we've just tested it here and calibrated what is going in here. Now we're going to look at not what's coming out, but what's coming out over here. which should be much stronger. Pin 3 of 6K7, that's this tube up here, up, there. Come around 3, 1, 2, 3. And the idea is the eye here should be, I should have to increase the attenuation. It's really not a very quantitative test, is it? 1, 2, 3. 3 right here. Oh. Big probe. 3 right there. Okay, so when I look at the eye, I see that it's overlapped. So, whoop. So the signal level increased. 3. Okay, as desired. Now I'm going to increase the attenuation. And reset this. Okay, wow, man. Now we go to the next tube, not the input but the output. Output of this tube. Next one over, pin 3 again. Pin 3, 1, 2, 3. Pin 3 is right here. Do we get an increase? Does the eye overlap? Well, I'm not even touching it, and there's already signal on it. So I'm not even touching the contact. I think the answer is going to be yes. I'm having a heck of a time seeing it. Every time I raise my hand, I put a shadow right where I want to go. 1, 2, 3. 1, 2, 3. Okay, we're on. I see an overlap. Wow. Okay, a lot of signal here. Let's get on it again. So, there we are. That's the signal there. That's the output of the second 6K7. So the IF has behaved just as it should. So we're all the way to the output of this tube here is strong. It heads into this IF. Guess what? This is the replaced IF. It comes out the other side and goes straight into these plates to be rectified. So I think I can just put the probe, I don't know for sure, I'll put the probe on the detector plates, and I'm not sure what to make of this now. Whether we can really rely on that, but let's do it. Okay, without adjusting anything now, we'll go on to detector plates. It's a little easier. There's nothing showing up at all. Oh no, yes there is. But not much compared to what was coming out of the second stage IF, which we would just repeat. 1, 2, 2 tube. Pin 1, 2, and 3. Pin 3. And that should close the eye. Ooh, it's really, yep, right on. So we got that much signal. Now, let's see if we can't get on the primary of this coil. I mean, it's pretty much the same thing. You know, really, it's just one wire. That's not going to make sense. I think we really seen the primary of that transformer is getting lots of juice. But by the time you get to the secondary, and I have to switch schematics because the schematics vary at that point. By the time you get here, the signal falls way off. So there's a problem with making this measurement because you know, I'm not too sure what to say, but I think because you're trying to snuff the RF out of this as you do the detecting. I don't know what to think. I actually contacted right on the plates here. That's where this contact went. And we saw very low. So what are the chances that this transformer is just so badly aligned? I'm on a false peak or something of that sort. I think what we need to do is fool the capacitor on. It's a capacitor, isn't it? So it can't be that far out. Well, we still got to fool with it. I think the problem is this, and it may be insurmountable. How to get more focused on this? How can you get more certainty of this? Signal goes into the primary, appears to be strong. Doesn't really show up in the secondary very much. Problems in the primary. Problems with the primary circuit. It goes straight off the coil right onto the B+ bus. What's the plate voltage on? Well, I bet you that 6K7 has the regular plate voltage on it. Does it? Does it really? Does it? Okay, so we're going to go from screen voltage measurement here. I'm going to pull this clip lead off. Okay, and we're going to look at plate voltage. Down on this meter, I'll have to tell you what it is. I have to untangle things. Which have become very tangled up. So we're trying to verify or discover the plate voltage of the detector. Plate voltage of the detector. Now wait a minute. Think about this. The plate voltage of the detector you're really talking about is a triode that's amplifying the audio. That's not of great interest. I've already tested the voltage rate on the plates of the detector here, and it's only the 5 volts. There isn't like 20 volts here and then it doesn't show up later. It's starting with 5 right here. Only get 5 if this tube's not working right, but it is working right. So only get 5 because there's only 5 available on the secondary. It comes back to the tuning of this and the chance that we're just, I don't know, something really wild has happened. Well, we're just going to fiddle wildly with the tuning of this thing and see what we can come up with. That's really the most I can suggest. So we'll put the meter, the meter I'm using here. We're going to stop looking at the I have to decide whether I want to stop the video or just keep it rolling while I make these kinds of changes. How about like that? That's easy enough, eh? Wouldn't you say? You can see that meter over there. Whoops, whoops, double whoops, triple whoops. Yeah, see, this is why sometimes I like to stop these videos while I do this kind of monkey business. There we are, we can see it now. That meter is going to be clipped to the plates. I'm producing a negative voltage, a small negative voltage. Okay, I am clipping it now. A small negative voltage. Okay. Let's tune the radio and make sure that's actually AVC showing up there. Just tuning the radio around. Let's hear it. It sounds pretty good, actually. So there's the peak. Now, this is on the 50 volt scale, so we're looking at 5 volts. I'm going to boost the signal going in and boost it. Okay. Okay, everything appears to be working right. Now, the objective is to monkey with that coil and end up with this voltage coming out a lot higher. And I'm probably going to monkey it right out of existence here. You know, another thing I could do is I could put the sweep. You know, another thing I could do is put the sweep through that. And I think someone whispered this to me a while ago. Put the sweep through it at a wide range and try to pick up its particular resonant point. Let's try the fiddling away idea first. So I'm in on one capacitor. My real expectation is this is only going to go down, down, down. Here we go. And it's tight. You know, the thing is, this is a capacitor, so I mean, you just don't have that great range. Man, that is really, it's just, you know, it's not the right coil. This is not the right transformer. I'm just trying to get in the other screw now. Here, there I'm in. It just jumped up a little wee bit. It's just not possible. There's another peak. Let me return it. AVC is fighting with me here. Let me just change the band. Oh, that won't work. If I change the band, we'll lose the signal. If I pump 455 through this radio and get an AVC voltage, I can then switch bands, and that shouldn't really change that voltage. Maybe there's an observation there that might be helpful in, you know, once again, further confusing the situation. So we'll go down to 455 here. 456 should come through. Okay, we're going to help it out a bit. Expect to hear him. Let's boost it again. There he is. Very strong. So I am pumping this in through the antenna. It's not the most appropriate way to do this. Did we get an AVC voltage? So I'm going to tune the radio now and see if that meter goes up now. No. Okay, I can cheat the signal level up over here. See if that produced an AVC rate yet. Why am I not getting anything here? Okay, so I'm going to switch the signal generator further up into the radio. Actually pump this signal in a stronger way. Okay, off the antenna. And now we're going to clip it onto the, let's try it, grid of the 6A8. Put it down lower. Okay, that's a 6 and 8. Still no AVC voltage there. No, there's no reason to tune this. Yeah. Tuning's not going to change anything, Jim. You're blah 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 blah. You're bypassing all that. Vary the input level. Watching the meter. Vary the frequency. So what have I done here? So I have a signal sent into the radio now at 456 or so. We're measuring the voltage at the detector, the output of the IF. So if we look at this on the eye, got the eye still on the screen. Detector output. Output of the previous tube on the other side of the third IF transformer. 1, 2, 3 right here. You see the test is clearly knocking down the test is interfering. Even though this is a really high impedance, you know, the circuits I'm working on here. So that signal goes into one side of the coil. The other side of the coil, primary coil, just goes to the B+ line. What's going on? So I am measuring it right up here, very high, but right on the other side, very low. So I can only take a wild guess. Okay, this is a wild guess. It's not the happiest guess either. Is the and this is a sad story if this is really the case. The original IF transformer in there got popped, and somebody went through all the effort of putting in another one and popped it right away. So if that were true, if it were popped open, if this were open circuit, there'd be no B+ on the plate. So that can't be the case. So this tube requires, like all tubes, to get maximum power transfer, you need to have the tube work into a resistance or impedance that is similar to what the tube itself, internal tube itself is. That's typically a few thousand ohms. So this coil should be a few thousand ohms to provide the right kind of, to get the maximum power transfer. Maybe it's not. It's not the right coil. Maybe this coil came from a radio, totally different tube here, or different circuitry. I'm not getting anywhere here at all. Well, we're going to do the IF, change the band. That's right. That's right, we were going to do that. Okay, so we're all set. Perfect. Good thing I just remembered what it was I was trying to do. So we're going to watch this as I change the band here. And it should not change. That's my statement. So that's an actual reading of 15 volt scale, 6 volts. Just over 6. Just over 6. That's different. Just under 8. Way down. So this is the short wave band. You can hear the sound in the tone you're listening to actually got quieter. Does that make sense? Less AVC, quieter. Less AVC. Because it's quieter. Somehow switching to this band has caused a reduction in the signal coming out of the IF from my signal generator. How can this do that? How can this change do that? That's the other shortwave band and this shortwave band. T'other and the other t'other. looked at the schematic, it seemed to me the switch position was essentially the same for both shortwave bands. That's true here. That's true here. It's true here also. So what I'm saying is switching between those two shortwave bands doesn't change the resistor arrangement here. So why would the radio behave differently? Oh my gosh, I'm sorry, I'm holding this in places you can't see what I'm pointing at, but I don't know if it really matters what I'm pointing at. Well, I think at this point I gotta stop and think about all this. You know, it's quite likely I'm just beating my head against a wall here. There's just no hope with this changed out transformer. It's just not going to do it. Yet I saw 15 volts some time ago. Okay, I gotta stop at this point. I got a massive amount of video here to deal with. So thanks for watching whatever it is I put together in post.